Welcome students. So in this lecture we are going to cover vector quick revision lecture. This is a quick revision lecture, means यहाँ पर सब कुछ जल्दी जल्दी बताया जाएगा. जो JEE नीट का एग्जाम देने जा रहे हैं, VIT हो गया या बिट सेट हो गया, जो भी एग्जाम आप देते हैं इंजीनियरिंग का या मेडिकल का, तो वहाँ पर वेक्टर की गरज तो हमको पड़ती ही है और वेक्टर बहुत इंपॉर्टेंट है. तो उसी वेक्टर का आज हम क्विक रिवीजन करेंगे. क्विक रिवीजन क्या होता है मैं फिर से बता देता हूँ. ये क्विक रिवीजन क्या होता है, आपको मोटा मोटा ज्ञान देता है. मोटा मोटा मतलब जो वाकई में इंपॉर्टेंट है. पूरा वेक्टर नहीं पढ़ाऊंगा, वेक्टर पूरा भी पढ़ाऊंगा लेकिन पूरा नहीं पढ़ाऊंगा. ऐसा वेक्टर आपको पढ़ाऊंगा मैं कि आप क्वेश्चन आराम से बना सकते हैं वेक्टर और वेक्टर के जरिए. और वेक्टर आपको पता है हर जगह काम आता है, हर जगह आपको रिजल्टेंट निकालने का जरूरत पड़ता है, चाहे कोई सा भी चैप्टर क्यों ना हो. तो आज मैं आपको वही सिखाने जा रहा हूँ. तो फिजिक्स क्विक रिवीजन आज हम यहाँ पर लेने जा रहे हैं. तो शुरू करते हैं. चलिए तो शुरू किए जाए. तो सबसे पहले डेफिनेशन एंड टाइप्स ऑफ वेक्टर. सो व्हाट इज द डेफिनेशन ऑफ अ वेक्टर? सो जस्ट लिसन, आई विल स्पीक मोर लाइक fast. I will be very fast this time. So what is the definition of a vector? So a vector is first of all a physical quantity. Vector is a physical quantity. There are two types of physical quantities we have. First one is a scalar and second one is a vector physical quantity. So the physical quantities are required to define the state of a system. To define the state of a system we need some physical quantity, just like mass, density, volume, velocity, then we have displacement, force, impulse. So these are different kinds of physical quantities, but few of them will just require magnitude and unit. Few of them will just require magnitude and unit, and some are unitless also. But these physical quantities are known as scalar quantities. But few physical quantities require direction as well, magnitude, direction and unit also, sometimes no unit. So these quantities are known as vector. So what is a vector? Physical quantities having both magnitude and direction. Representation of a vector. So to represent a vector, just draw an arrow. Just draw an arrow. That is all. If you draw an arrow, that is the representation of a vector. It means the length of this vector will give you the magnitude of the vector and this is the direction. So this arrow will represent the direction. How to represent? Let us say this is a vector A. So either you can write a vector or you can just do it like this again and again. So make it dark. So this is also a vector, and some people like this. They do write it like this, a bar. So a vector, jada wala a or a bar. So these all are the representation of vector. This is a vector. So a vector should have magnitude as well as direction, and unit is there always. It may not be there for unitless physical quantities. So a vector का representation हो जाएगा उसका magnitude. देखो जब भी किसी का मैग्नीट्यूड लिखते हैं तो लिखते हैं उसको मॉड ए से, और डायरेक्शन लिखते हैं तो लिखते हैं ए कैप. ए कैप, व्हाट इज ए कैप? ए कैप इज द यूनिट वेक्टर अलोंग ए वेक्टर. यूनिट वेक्टर अलोंग ए वेक्टर. व्हाई इट इज कॉल्ड यूनिट वेक्टर? बिकॉज यूनिट वेक्टर इज जस्ट रिक्वायर्ड टू गिव द डायरेक्शन ऑफ द वेक्टर. यानी कि केवल वेक्टर का डायरेक्शन देने के लिए ही कोई भी टोपी पहन के आता है. तो ये टोपी पहन के आया है तो ए कैप इसको बोला जाता है. सो इट इज ओनली गिविंग द डायरेक्शन. Its magnitude must be 0. यानी कि mod of a cap should be 0. That is what is the definition of unit vector. Unit vector must be having magnitude equal to 0. So representation of vector is like this, and this length will give you the idea of the magnitude. So polar vector, there are two types of vector we are going to see. है ना? यानी कि तो मोटे-मोटे तरीके से दो तरीके से बांटा गया है. First is polar vector, second is axial vector. So these are those vectors which have a starting point, and in case of displacement or a point of application in case of force. So these forces will be having some starting point and a point of application. So whenever we apply some force, there must be a point of application. Whenever we start our displacement, there must be some point of start. So that vector is known as polar vectors, right? And the example of displacement, velocity, momentum, force, etc. are example of polar vectors. They must be vectors first of all, okay? Then only they will come in the category of polar vector. Then we have axial vectors. So these are those vectors which represent rotational effect and act along the axis of rotation in accordance with right hand screw rule. You know the right hand screw rule, right? So I'm not here to just tell you about right hand screw rule. That I will cover in the different lecture. So angular velocity, torque and angular momentum are examples of this type of vectors. So just like r cross f, r cross p, v cross b, such vectors are polar vectors. So they give you some sense of rotation. So these are the vectors which represent rotational effect and act along the axis of rotation in accordance with the right hand screw rule. So such things are angular velocity, torque, angular momentum. These vectors are known as axial vectors. So we have, in most of the time we are going to deal with polar vector, but in rotation also we deal with axial vectors, not angle between two vectors. So angle between two vectors. Let us say two vectors I am having. That is A vector and this is B vector. So this is called head of the vector, this is called tail of a vector. So head and tail. So the direction of vector should be from tail to head. The direction of the vector should be from tail to head. Okay. So to find out the angle between two vectors, first of all, angle between two vectors can be from 0 degree to 180 degree. The minimum angle between two vectors can be either 0 degree, can be 0 degree, and the maximum angle between them can be 180 degree. So whenever you want to measure the angle between two vectors, you must know that their head should be connected or their tail should be connected. So here I can see that their tails are connected. So simply this theta is the angle between A vector and B vector. What if it comes like this? What if it comes like this? Just see. What if it comes like this? And this angle is theta. So my dear friend, here tail of A vector is connected to head of B vector. So this theta is not angle between A vector and B vector. If you want angle between A vector and B vector, you must displace this B vector in such a way that it becomes like this. And you have to push B. You can either push B or you can either push A. A को इधर भेजो, B को उधर भेजो. So ये हो जाएगा 180 minus theta. So 180 minus theta is the angle between A vector and B vector. So the angle between A vector and B vector, between two vectors, can be from 0 to 180. Not greater than 180. It cannot be greater than 180. How can it be? It cannot be greater than 180. So be careful. Okay, next. So unit vector. I already told you. A vector is A K cap. A cap. So this you can write mod of A as A only. So whenever you see the magnitude, that is A. So A vector magnitude mod of A vector is A. So it is read as A cap. So A cap का फॉर्मूला क्या आ जाएगा? यहाँ से हम देखेंगे तो वेक्टर अपॉन उसका मैग्नीट्यूड, वेक्टर अपॉन उसका मैग्नीट्यूड ऐसे लिख सकते हैं, है ना? mod of A. Equal vectors क्या होंगे? These are two equal vectors, A vector and B vector. These are two equal vectors. Why they are called equal vectors? They are having same direction and same magnitude. Then they are called equal vectors. Opposite vectors, A vector and B vector are opposite vectors. These vectors will be having same magnitude but opposite direction. It can be written A vector is minus of B vector, or you can say the sum of two vectors will be 0 when they are antiparallel, or you can say opposite. Sorry, antiparallel and opposite. Okay. Null vector, it means A vector equals to 0. This is called null vector. So null vector has magnitude 0 but no direction. Its direction is not defined. Direction is not defined for which vector? Null vector. Null vector having magnitude 0. Parallel and antiparallel, parallel vectors are having same direction, just like A vector and B vector. So they are having same direction but they may have different magnitudes. So what is the relation between them? B vector is lambda A vector. If two vectors are written like this, by this relation, B vector is lambda times A vector. Lambda is a number here. Lambda belongs to a real number. Then if lambda is greater than 0, A vector parallel to B vector. And if lambda less than 0, A vector is anti-parallel to B vector. So be careful. It depends on lambda. Lambda positive, then parallel vectors, lambda negative, then anti-parallel vectors. Okay, so this is asked so many times. So they both will be having the same direction, but their magnitude will be like this. Magnitude of B will be lambda times of magnitude of A. So many times the question has been asked from this topic: parallel vectors and anti-parallel vectors. So be careful. So whenever you multiply a vector by some number that is positive, then the answer will be a answer will be a parallel vector to that vector. And if you multiply it with some negative number, then it will be an anti-parallel vector. Okay, what is position vector? Position vector is simply known as, it is the vector which defines the position of a vector with respect to origin. Just like this point P. This point P here. You can see this point P here. So this point P having coordinate x, y, z, and this is the origin. So this is called position vector. Position vector will give you position of a particular point with respect to origin. So P vector is R vector comes out to be x I cap plus y j cap plus z k cap. What is I cap, j cap, k cap? I cap is the unit vector along x axis, j cap is the unit vector along y axis, and k cap is unit vector along z axis. Minus I cap is the unit vector along minus x, minus j cap is the unit vector along minus y, and minus k cap is the unit vector along minus z. So be careful, this is how we represent. This is also called OP vector. So let us say you have a vector like this. This is a point A, that is x1, y1, z1, and point B, that is x2, y2, z1. And you are asked to find out this vector, which is moving from A to B. And A being tail and B being head, then our vector will be x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So be careful. If somebody asks the magnitude, so what you have to do? You have to simply find out the distance between 2 points. So magnitude of R becomes under root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. This is how we calculate the magnitude. Z2 minus z1 squared. Okay. And if you are just given a vector, let us say 2i minus j, or let us say ai cap minus plus b j cap plus c k cap, then magnitude of mod of R will be under root of a square plus b square plus c square. That is all. Okay, next we have addition. Addition of vector, law of parallelogram. And addition of vector, we use triangle law for vector addition. So just see how we use triangle law. So let us say this is a vector, let us say this is b vector, and this is c vector. So I have to apply triangle law here. I have to apply triangle law here. So what you have to do? Just move in the loop. If you are going from minus to tail to head, take it positive. So plus a, again tail to head, that is plus b, head to tail, that is minus c, equals to 0. यानी कि algebraic sum of all the vectors in the loop should be 0. Let it be triangle, let it be rectangle, let it be pentagon, let it be anything, let it be any gun. So in any gun, if you move in loop, if you are taking tail to head as positive, you have to take head to tail as negative. You can move anti-clockwise, you can move clockwise. It depends on you completely. So let us say, I will make like this. This is my A vector, B vector, C vector, D vector. So this is something, right? So from here to here, tail to head, that is positive. Plus a. Tail to head, that is positive. Plus a. Head to tail, that is negative. Tail to head, that is positive, equals to 0. This is how we calculate. Okay. So what is this resultant means? Resultant means addition. If it is written, then R vector is equal to A vector plus B vector. Its meaning is that R vector is the resultant of A vector and B vector. Okay, one more thing I should tell you. Let us say R1 vector is A vector minus B vector. It means R1 vector is resultant of A vector and minus B vector. So whenever plus sign comes between two vectors, that defines the resultant. It is not like that R equals to A plus B. No, my dear friend. This is not what it is. This R vector is equal to A vector plus B vector. Because while dealing with vectors, the concept is different from while dealing with scalars. Just like 2 kg plus 3 kg becomes 5 kg. But 2 I cap plus 3 j cap does not become 5 I cap or 5 j cap. That is wrong. So while dealing with vectors, we have to apply some law. That is called law of parallelogram. Law of parallelogram. Okay. So in this case, you have two vectors, A vector and B vector, making some angle between them theta. Then the resultant means A vector plus B vector. Resultant of plus A vector and plus B vector will be like this. That is R vector. First of all, you should know that the resultant of A vector and B vector comes in between them. in between them. Somebody can say, sir, this is also in between, but this angle is greater than 180 degree. So what I told you, the resultant will come on that side only where the angle is less than 180 degree. So this theta is less than 180 degree, that is why R comes here, not in this region. So in this region R vector is not possible. R vector will be in between A and B in the side where theta is less than 180. Okay. So here R comes, and R will be more closer to the one who is having higher magnitude. So let us say if A vector magnitude is greater than B vector magnitude, then R will be closer to A, not B, far away from B. Okay. So let us say this angle is alpha. So this R magnitude of R, mod of R comes out to be under root of A square plus B square plus 2AB cos theta. That is very simple. That is law of how we are not worried about it. But simply remember, if two vectors A and B making angle theta between them, and the resultant is R, then R will be having the magnitude under root A square plus B square plus 2AB cos theta. Theta is the angle between A vector and B vector. I have told you how to find out the angle between A vector and B vector only when their either heads or either tails are correct. Okay. So direction of R can be defined. Direction of angle, that angle, alpha. So tan alpha will be B sin theta upon A plus B cos theta. B sin theta upon A plus B cos theta. Okay. And if this is beta, this angle is beta. If this angle is beta, the tan beta will be A sin theta upon B plus A cos theta. So you must remember these two formulas. Okay, what is alpha? Alpha is the angle made by the resultant with A vector, and what is beta? Beta is the angle made by R vector from B vector. Okay, next special case for resultant. So special case for resultant, what are the special cases? Just listen carefully. When two vectors are perpendicular to each other, let's say first case is when they are in the same direction. When they are in the same direction, then the resultant will be having the maximum magnitude it will be having. Just like if this is A vector and this is B vector, then resultant will be simply A plus B. Resultant will be simply A plus B. And this is the maximum resultant one can have. And when theta is 180 degree, so this is theta 0 degree example. When theta is 180 degree, A will be here, B will be here. So resultant will be A minus B. That is minimum. So what is minimum? Minimum is A minus B and maximum is A plus B. So two vectors can have minimum resultant of A minus B and maximum resultant of A plus B. Theta is 0, then A plus B, theta 180 degree, A minus B. Okay. What if theta becomes 90 degree? So if theta becomes 90 degree, A will be like this, B will be like this. So resultant will be like this. So resultant will be under root of A square plus B square. And if you want to calculate tan alpha, so tan alpha will be what? B by A. Simply, if alpha is the angle made from A, then it should be B by A. And beta is the angle made from B, then it should be A by B. Yani tan beta will be A by B. So this is very simple. If both becomes equal, theta 90 as well as A equals B, then this is also A, this is also A. Then the answer comes out to be exactly in between. Resultant. So my dear friend, please remember, when both of the vectors having equal magnitude, then the resultant will be just in between, in the middle, exactly in the middle. So let us say A vector having angle 90 degree in between them, then the resultant will be having magnitude under root 2A, and it is exactly 45 degree. And what if the angle is 60 degree? Let us say this is A, this is A, and this is 60 degree. Then resultant of both of them will be root 3 times of A, and that is 30 degree. What if this is A having angle 120 degree? Then resultant will be A only having angle 60 degree from both of the vectors. So angle 90 degree, angle 120 degree, angle 60 degree, and B having equal magnitude also as resolving vector. So resolving vector is very easy. How to resolve? So let us say this is a vector A, and this is angle theta. So resolving means to take components. So we can take two perpendicular components. So this will become A cos theta, and this will become A sin theta. So where it will be cos theta? थीटा के पास वाला क्या होगा cos थीटा, थीटा से दूर वाला क्या होगा sin थीटा, यानी कि जिससे थीटा बनेगा वो that becomes cos theta और the second one is called sin theta. Let us say this is A, then I can resolve like this, and if this is alpha, so this will be A cos alpha and this will be A sin alpha. That is all. That is how we do it. So resolution of vectors. So next comes out to be multiplication of vectors. Okay, one more thing remains here. Let me tell you what is this. Let us say if it is given like this, A vector and minus B vector. So what is this? Resultant of A and minus B. So earlier A was like this, B was like this. But minus A will be where? So minus A will be like this. Where will be minus B? So minus B. So now I want to find out resultant of A vector and minus B vector. So it will be like this. So this is R. And the magnitude of this R will be at the root of A square plus B square minus 2AB cos theta. Because now it was not angle theta. Now the angle becomes 180 minus theta. Now the angle becomes 180 minus theta. So whenever we are using, in earlier case we were using angle theta. Now we have to use angle 180 minus theta. Because theta was the angle between A vector and B vector. But now the angle between A vector and minus B vector becomes 180 minus theta. So we will use the same formula, but theta will be replaced by 180 minus theta. Okay, so let us go ahead. Multiplication of vector. So when a vector got multiplied with a scalar, that is the parallel vector, like lambda times A. So it will be B vector. B vector will be parallel to A vector. This is force barabar mass into acceleration. Force equal to mass into acceleration. So acceleration, which is a vector, got multiplied with a mass, which is a scalar, gives you force. That is a vector quantity. So whenever a vector got multiplied with a scalar, the answer will be a vector only. That will be the parallel vector, or it may be anti-parallel if that scalar things is negative. Okay. So vector to vector multiplication is of two types. Vector to vector multiplication is two types. First one is scalar product. Second one is dot product. Both the products are very important for us. Both the products are very important for us. Scalar product. In scalar product, if we multiply two vectors, then the answer would be a scalar only. And if we multiply two vectors, if the answer is vector itself, then it is a vector product. So dot product can be written as A dot B. A dot B means AB cos theta. If A and B having angle between them theta, then it will be AB cos theta. So theta becomes cos inverse A dot B upon AB. What is AB? A is the magnitude of A vector and B is the magnitude of B vector. Okay. And in case of vector product, it is A cross B. A cross B means its magnitude will be AB sin theta and it will be having some particular direction. Because in vector we will have direction also. But here we only have magnitude. But here we should have direction also. So in this case, if I write, so this is A is like this, B is like this is theta, then A dot B will be AB cos theta. That is a scalar. That is a scalar product. Okay, so cos theta becomes AB upon A dot B upon AB. How to calculate dot product? So in case of dot product, you must know I dot I equal to 1, J dot J equal to 1, K dot K equal to 1. What is I? Mod of I, mod of J, mod of K equals to 1. Because they are unit vectors. So I dot I 1, J dot J 1, K dot K 1. When two vectors are perpendicular, then dot product becomes 0. Why? Because theta 90 degree, then cos theta will be 0. So A dot B 0 implies A vector and B vector are perpendicular to each other. We are going to use this so many times. So it is used to find out the angle between two vectors. For two perpendicular vectors, it is 0. If it is written like this, A cap dot A cap, then it becomes 1. And if written like this, A vector dot A vector, it becomes A square. So be careful. So this is very easy actually. I dot I, J dot J, K dot K. If like one example is given like this. So let us say 2I minus J dot 3I plus J. You have to write dot product. So what you have to do? I को multiply करो. So I कितना है 2. So 2 into 3. J को multiply करो. J कितना है -1. So -1 multiplied by 1. So 6 minus 1, that is 5. This is how we calculate dot product. Cross product is very easy. By the way, this dot product follows. This is commutative. A dot B is equal to B dot A, and this is also associative. A dot B plus C A dot B plus A dot C. Here we have direction as well. So AB angle theta, then magnitude will be AB sin theta only, but we will be having direction, and direction will be like this. Direction we have to calculate from the right hand thumb rule. Right hand thumb rule, what does it say? If you want to A cross B direction, then the direction will be A cross B divided by mod of A cross B. Mod of A cross B will be what? AB sin theta. Mod of A cross B will be AB sin theta. Okay, right hand thumb rule we have to use. We have to curve our fingers from A to B, then the direction of A cross B will come out. And just know, if C is A cross B, then C will be perpendicular to A, C will be perpendicular to B. Or let us say C will be perpendicular to the plane containing A vector and B vector. So very clear from here. So C dot A will be 0 because they are perpendicular, C dot B will be 0 because C will be perpendicular to the plane containing A vector and B vector. From here also, one thing you must know, let us say A vector is x1 I cap plus y1 j cap plus z1 k cap, and a B vector is x2 I cap plus y2 z cap plus z2 k cap. Now if A cross B is asked, how to calculate that? So simply make a determinant like this. First A you have, so x1, y1, z1, x2, y2, z2, and solve this determinant. How to solve? I cap y1, z2 minus z1, y2 minus j cap z2, x1 minus z1, x2 plus k cap x1, y2 minus x2, y1. That is how we calculate. And to find out the magnitude, just I वाले का स्क्वायर, j वाले का स्क्वायर, k वाले स्क्वायर का स्क्वायर रूट आप ले लीजिएगा, वहां से वो आंसर आ जाता है. ठीक है. So this is how we calculate. Here I cross I becomes 0, j cross j becomes 0, k cross k becomes 0, and follow this rule I j k. It means I cross j will be k. If you are moving like this, use plus sign. If you are moving like this, use minus sign. So I cross j is k, j cross k is I, and k cross I is. If you are moving anti-clock, then it will be minus. I cross k minus j, k cross j minus I. Okay, so be careful. The application of this rule, this product rule is where used to vector product for finding out the area of parallelogram. So area of parallelogram, let's say this is AB vector, this is AC vector. So this is a parallelogram you have. So area will be magnitude of A cross B. Magnitude of A cross B means AB cross AC. AB cross AC. If you are to find out area of triangle, then triangle area will become half of AB cross AC. So this is the use. Okay, last few things we have, like projection of vector, scalar and vector, direction, cosines, and importance of vectors. So just see fast. So what is projection of vector? Projection of vector means projection is called chaya. Chaya means percent, shadow. So let us say if we have this vector A and this vector B and angle this theta. So projection of A on B will be projection of A vector on B vector will be A dot B, or you can say A cos theta. A cos theta. A cos theta multiplied with B, divided with by B. So A B cos theta becomes A dot B, and this is B. So this is scalar projection. Theta is the angle between them. So this is the called scalar projection. उल्टा पूछेगा तो क्या करते रहेगा? उल्टा मतलब projection of B on A, it will be A dot B upon A. What about the vector projection? So in vector projection, what you have to do? A dot B upon B multiplied by B cap. And what is B cap? B cap is the direction along B vector. So that is B vector upon B. So this becomes A dot B upon B square B vector. So this is how you can solve this. So scalar projection and vector projection. Scalar projection is asked most of the times. If nothing given, then it is asking scalar projection. One more thing you must remember, that is direction cosine. What is direction cosine? Let us see. अगर मैं लिखूं a dot I can, what does it mean? It means that component of a vector along x-axis. That is what it means. When I write a dot b can means projection, the component of a vector along b, or projection of a on b. Okay. So what is direction cosine? Direction cosine are called cos alpha, cos beta, cos gamma. What is alpha, beta, gamma? Alpha, beta, gamma are the angle made by a vector from x-axis, y-axis and z-axis. It is called L, it is called M, it is called N. And the relation between them, L square plus M square plus N square is equal to 1. How to find out cos alpha? Cos alpha will be A dot I upon mod of A. What is cos beta? Cos beta is A dot J upon mod of A. And what is cos gamma? Cos gamma